Okay, welcome to our last session of the day, and I think you'll be glad that you stuck around to hear this session where Don Grigg of Tekla, I'm going to introduce him and he's going to introduce the rest of his team, but they're going to show us how we take the 3D model that most of us are used to working with in the steel business, how they take that 3D model into the field and applications that it has out on a job site. So without further ado, I'm going to turn it over to Don.
Thank you, Duff. Thank you very much. Well, folks, it's good to see you guys here. I know it's the last session, but we're glad you stuck around. I think we've got a good crowd. We've got a lot of good players. I think most of us know you guys, and I think most of you guys know us, so I think we're in great shape. But what our goal is, what our goal has been all along, I've been attending these things for about the past 6 years, is to let the erector become part of the BIM process. How many people with a quick raise of hands know what BIM even means? I'm not going to question. Okay, so everybody's kind of heard of it in here. Because what was happening is the fabricators, the engineers, they were taking advantage of the data that was stored in the model, and the erector, in some cases, is taking advantage of it, but there's a lot of data that you can take advantage of, and you also can help you manage the model as well. So I need to move on. All right, so we're going to talk today about BIM to field. Our players here today are going to be from Tekla Inc., representing Tekla will be Mark Alphen. He's actually a licensed structural engineer. He's our steel segment manager of North America, and he's 8 years in the structural steel detailing industry. Mark, if you will. Then myself, I think most of you guys know me. I'm the sales guy for the South and play a little bit of golf, not enough. Nice hat there, Gov. People also call me Gov. And then Ian Coase is going to be our technician from Tekla, and Ian's been 20 years in the steel business. And this is 10 years using 3D modeling in the 3D modeling environment, and it's his 5th year with Tekla, and we're glad to have him. And then beyond that, something else we're excited about is Trimble navigation. If you guys haven't seen Trimble, as Tekla has a great tool with Tekla Structures, Trimble also has a great tool and an amazing tool to help you get the accuracy you can in the field and put that back into the model with Tekla. And we're real excited to show you this as well. Company info, a little bit about Tekla. Tekla, as you guys have bought software in the past, a lot of the companies come and go. Tekla is very well established, been around since 1966. A publicly held company, software solution for building construction, infrastructure, and energy as well. We are easily the leader toward BIM, building information modeling. As a matter of fact, I've had quotes from people who did not work for Tekla say that Tekla was BIM before BIM was BIM. And actually, there's some truth in that, because back in the day when we had Xsteel was actually started in 1993, we had plans for this. We had plans to integrate different disciplines into one model, and also to help the general contractor, help the fabricator, help the concrete fabricator, help everyone manage the project through 3D modeling. So our vision was there even back then. Our annual income is 50 million euros. Sorry, that's in euros, but it is, which probably means about, I don't know, $25 US at this point. Hopefully it will get better. As I mentioned earlier, we do have a tool that reaches all parts of the construction industry, not just steel, not just concrete, and not just engineering. And you can see it starts, we have some fabricators who are starting in sales and bidding, doing cost estimating. Then we have fabricators and engineers doing conceptual design. Then, of course, they're creating the erection drawings from it, getting the benefits from it, detailed shop drawings right out of the Tekla model. Purchasing, bill of materials, again, right out of the model. And of course, fabrication integration, CNC files, different type of communications, different type of reports sent right to the shop. And of course, the communication going backwards from the engineer back to the steel fabricator and also to the steel erector at this point. And then erection scheduling. Tekla does have a product, let me say this a little louder, Tekla does have a product that will let the erector help him plan his job site, help him plan his project, and help him follow up and plan not only before he gets to site, also on site. And then, as I mentioned, you can do project management with it. Everybody's leaving. Okay, don't leave too quick. All right, the program today, we're going to give a review of existing tools in Tekla, site layout, erection planning, surveying, site verification, including Trimble, and Mark and Jim's going to do a presentation on that. And then I'm going to show a presentation of a new product we've got called Tekla BIM Site. And we're really looking forward to showing you that as well, and then get everybody excited about that, because I think you'll like the price point on that. So now, with further ado, I'll let Ian come up and get started talking about Tekla.
Thanks, Scott. Hi, good afternoon, everyone. What I'll do is I just want to quickly review a few of the tools that we've had already existing in the software. If you've attended any of these sessions that we've done in previous years, then you may be familiar with some of this stuff. If not, then it may be new to you. I'm going to start off with just a little bit of model orientation. You've probably noticed by now that white man speak with forked tongue. I've got a little bit of a strange accent, so you'll all go home talking like Shrek tonight. So we'll start off with this, basically the model, a real prototype structure of your final erected building. And typically, if you're an erector, this is going to come to you from your fabricator, from the engineer, somebody like that is going to share this model with you in many different disciplines. And we'll talk a little bit more about the different formats and things that you can have later. But crucially, you'll see this is an exact replica, as I mentioned, of the final structure. And there's a number of things that we can do with that Tekla model. For example, you'll see if I slice through this building, you can see that I have all the connections in there. I have all the bracing stuff in there. And I can also spot easily where the detailer maybe has made a pretty glaring error. But you can see every bolt, every weld, every nut, every washer, everything is all in there. The deck, downspouts, you name it, anything you want to show within that Tekla model. We can even put some koi in this pond if you want as well. The idea here then is that we can use this model for a whole bunch of different erection-focused features. And this is a couple of things that we've been pushing over the past few years. Just get my cheat sheet here. I'll clear out a lot of the architecture, a lot of the non-steel based stuff by just changing a quick representation here. I'm going to say I just want to see the steel material. So that'll strip off all the glazing and the concrete curtain walling and stuff like that as well. So I can see the steel nice and clearly. We can do things like record statuses and things like that in the Tekla model. For example, if you want to account for your daily work, you could write it on the back of a cigarette packet, or you could record it on a spreadsheet and import that into the Tekla model. Now we have a bunch of different options in here. We call them user-defined attributes. But basically some information that you can then complete into these boxes and share that with the engineer, the client, whoever's paying the bills at the end of the week or the end of the month in the terms of reports. So like for example, I will say, got workflow. You might say like the date it was received on site or anything like that. The date, project stats, here we go. The date erection started, and also the status of any particular piece. Now you can control what these guys are. It may be that it's arrived on site but it's not erected yet. It may be that it's got a problem that it can't be erected, or it may be just going ahead and marking things as installed. So for example, what I'll do is I'll highlight a bunch of members here, and I'll just modify that to mark them as installed there. And you can actually see if you do like a representation on that model, you can colorize that model based on your process or on your progress even. For example, color by attribute, and I'll say site status. So what we're seeing here, if I zoom out a little more in the model, is you can see as we progress through the erection sequence, you can see as we mark each thing as erected, we're starting to color in the building, if you like. Kind of like the model version of the highlighter pen with the chart on the sheet or the cabin wall, yeah? So an electronically recorded method covering all of that information. Then there's all sorts of other tools as well, and I won't go into these in too much detail, but suffice to say that there's things like lotting, for example, where you can lay out how many trucks you've got and what the capacity of your trucks might be, and assign different items onto those trucks. You can also create tasks if you're programming or if you're planning the erection and things like that. You can use this task manager within the software, which will, once it loads in a few seconds, you assign like the rate of erection. Perhaps you can do 5 columns per hour and 15 beams or something like that. Then you can assign those tasks to a workflow, to a rate, and then calculate how long it's going to take you to erect each individual phase or the entire structure or anything like that. So I'll say, for example, this is a new task, and I'll say erection phase 1, something like that. I'll say I can erect 2 pieces per hour, for example. I'm planning to start it today. As yet, I don't know when it's going to be finished, but I'm going to select all those guys there. Excuse me 1 second. Let's go here. So I've got all those pieces selected, and I'm going to add those selected objects, and you should see that this timeline will modify to give me the time that it's going to take to erect all those pieces based at that work rate. So you've got some advanced planning tools in there that you can use to your advantage as well. You can also do things like create dependencies and things like that as well. So if phase 1 has to be erected first before phase 2 starts, then you can depend phase 2 upon phase 1, all of that information. The next thing you might want to do is you might want to actually physically plan your erection sequences. Now I'll just set this back to the standard representation right now. And what we're going to do is we're going to go through the building and decide on the process that we're going to erect. So, let's see, here's my animation tool down here. I'll clear out the existing ones. So I'm going to start with a plan of my entire building, or a 3-dimensional view of my entire building, and I'm going to say the first guy I'm going to erect is this column right here in the corner. Then, of course, I've got to erect this column next, and then perhaps I can put this beam up, and then I can put this column up, and then this beam. And what I'll do is when I save that, you'll see that they appear in our sequence list. Now I can move those up and down, I can adjust them, and I can also do other things as well, like interrogate them for any weight and things like that as well. Now, as you're planning the erection, you can see there that each individual item is disappearing from the model. To show that I have already flagged that as available for erection in the sequence. So I'll go ahead and save that sequence there. Just save that as an animation file there. And I'll close that guy down. And I'll bring up the tool that we've been really pushing over the past couple of years, and the thing that we've found has been real popular with our attendees and our users is this crane console. The idea that we can almost virtually drive a crane within the Tekla model. And that's going to be good for testing erection sequences for safety, producing method statements, or anything like that. So I'll bring a crane into my model, and I'll place it. And also the visual model gives you some options in terms of you can easily see how much steel you can reach because you know the length of the crane boom, for example. And we can set that. You set the properties of the crane that you might be using. For instance, what weight is it capable of? All of that kind of information can all be added within here. And we'll change things like we'll make the boom length a little bit longer, say 80 feet long. And as I modify that, you'll see how the crane is able to reach a lot more items in that model. And we can do other things like this as well. Create a nice quick report of all the stuff that the crane can reach within there, based on the true center of gravity even. So although one of those members might be out with the crane's physical reach, the fact that you're going to be lifting it from a certain point means it might still be erectable. So if I do this crane reach report here, it'll take a few seconds. Well, let's get our crane selected first. So you can see how I'm able to actually almost sit in the cab and drive that crane, put the hook out and then lift the hook up and down. So what I'll do is I'll run that report now just to give me my crane reach report. And after a few seconds, what it's going to do is it's going to highlight each member that I can reach within the bounds of that crane based on the center of gravity of the finally fabricated assembly. You can see you get like a text-based report on it, and you can use that to click on different things if you wanted to check for everything, a certain thing that was over a maximum weight or over a maximum length that was capable. You could find that by clicking on the text-based list. But you can see there quite easily what I'm capable of erecting in that model, all the stuff that's highlighted bright orange. A couple of other things that we can do with that include pulling the animation file and actually showing the erection sequence as an animation. So what I'll do is I'll even just bring a truck into my model here. And this is just a basic object brought from another CAD program, for example. A simple looking truck there. But just to show like on site where you might be placing your delivery zone or anything like that. Then what I'll do is I'm going to say, right, I want to run this erection sequence based on an animation file to erect all these members. So what I'll do here is I'll pick my truck point here, and then I'll pick my animation file. That'll be stored within my model here. So once I open that up, and then you can see I start the animation, and you'll see as I'm walking through that model, it should, if I click play here, okay, a point there. You can see there it picks the beams and columns off of the truck, swings around and erects them. So as you're proposing this as a method statement perhaps for erection, cancel that. You can check and see if there's going to be any potential. Yeah, I made my crane stretch too far. But you can check there, like make sure the area around where the crane's going to be swinging is clear. Make sure that the stuff that you're erecting is in the correct order. Make sure you're not erecting a beam before you're erecting the columns that are going to support it. So these are a collection of tools that we've had in the software for a little while now, available within the standard Tekla Structures program. If you want more information on that kind of stuff that's existing already, just grab Don or Mark at the door later on. We're going to start to look onto some of the more newer stuff now that we're bringing in. Let's just bring that, close that. And I want to introduce, are you going to bring Jim in right now? We're going to talk a bit more about using the Trimble machine for site layout.
You know, guys, and keep in mind with that animation, it's pretty and all, but think of it like this as well. When you take it for a bid or you're going to a general contractor, you can show him your layout yard. You can show him what your crane plans are. Tekla can set it up to where where your truck enters the yard, enters the site, if you will. Also where your crane would enter and your crane path. So it can do much more. And keep in mind, guys, Tekla is just a great tool, but it's only as good as the user. And if the user says, all right, I want Tekla to do this, then guess what? He can find a way to do it in Tekla. Now I'll introduce Jim again, Jim McCarthy. He's with Trimble, and he's going to show you a way with how Trimble can interact with Tekla, and also how it works in the field, if you will. Jim?
Excellent. Thanks, Don. So I think everyone's probably wondering why I'm here, frankly. This is kind of a new aspect of what we're trying to do. We've had a relationship with Tekla for about 3 years now, and it all stemmed from some discoveries we made a few years ago that while the whole concept of BIM and virtual design and construction has been a very aggressive trend in the industry, the fact is most companies keep it in the office. It keeps contained within the office, and once we get to the field environment, which is very, very critical for what you do as steel erectors, typically people go back to the old antiquated methods of tape measures, string lines, plumb bobs, and things like that. They work, they're fully functional. Okay, I didn't know if my time was up already. Thank you. So what we're trying to do is we're actually trying to initiate a concept called BIM to field. So Ian has shown you what you can do with the model in Tekla structures. Our goal is to extend that model to the field using the latest technologies to give you the most accuracy, the most productivity, to try to open up new workflows and actually be able to see what's going on in the field on an immediate basis, to understand that that wonderfully detailed model that you've taken all the time to create is actually being duplicated in the field. So what I'm going to do today is I've got a couple of slides here to kind of show you some of the process, some of the use case, and then a quick case study. Then we're actually going to fire up this robotic total station and do a little bit of layout in the room to kind of show you how we would do it in the field. Certainly afterwards, if you have any questions, flag me down and I'll be glad to answer them for you. Okay? Or during the presentation, feel free as well. So, whoops. Need to go here. So I think first, what's interesting to me is we've really been doing this for about 8 years now, primarily with general contractors and concrete construction. Over the last year or year and a half, we discovered that the steel industry is probably one of the most advanced industries as it relates to using software and modeling and coordination amongst the fabrication, detail, design, and erection community. The general contractors and concrete guys are coming in behind you guys. So you were really the pioneers of the industry. So in our opinion, and the way we've seen and in talking with some of the contractors, it's ripe for technology. You're already using a lot of the modeling technologies. The field technology shouldn't be a hindrance, and it should be a really well accepted technology in your industry, and that's what we're hoping to show today and in the future. Some applications. So you're probably wondering, well, what do we use this for? So I think in the industry, certainly with fabricators, there's a lot of different places we can use it, which ties directly to what you do. Certainly you get all of the equipment or the components that come out of the fabrication industry. So our goal is to allow the fabricators to use these technologies to get much better as-built information, existing site information, so that they can fabricate more accurately, more precisely, and provide you with the tools and the equipment or the actual components to actually put it together so it works. These days there's a lot more renovation and rework going on. The fabrication process is real critical to making sure that it connects properly. So from the fabrication standpoint, that's pretty easy to understand. From the erection standpoint, it's equally as important that you know when you bring your equipment to the job site, when you've got crane time reserved, and you've got a yard full of steel components that have to be put together, that what's on that site is properly placed so that when you go to put a column out there or you go to lift a truss in place, all of the supporting components and the tie-down locations are properly placed. So this is a real quick, easy way to first of all know what's there, know it's in the right place, potentially bring it back to the model, and then prove to the fabricator maybe there's an issue or a problem so that you can take care of it before you actually get to the field. And that's the real key, is when do you find your issues? When you're in the middle of placing a truss or after or before you actually even reserve crane time and go out to do it. Oops. What we got going on? Oh, duh. Too many computers. So I think the other thing that we have to look at relative to the erection process is something, a couple words about tolerance. So when things come out of the fabrication facility, there are certain tolerances that the fabricators are required to abide by. It can lead to some things like you see up here. I-beams that aren't necessarily square because the tolerances allow for it. Potentially some camber, some deflection. Things that are a little bit more difficult from the erection side to worry about when you're trying to place things together. So understanding that those things exist, we have to have technologies or ways that we can minimize the potential problems. This is obviously a massive base plate for a column. If you came out to a job site to place this particular column and these bolt placements were not correct, you'd have a serious issue. There is some slop or a little bit of play in there, but the fact is knowing that that's wrong or knowing you've got a potential issue before you get there is key. That's a critical component. Obviously, with large components like this, knowing that what you're bringing out to the field is going to fit before you do it is the critical aspect as well. So from a process standpoint, If anybody in here is aware of how the process works within your company, how many of you use surveyors to actually check bolt positions or help with placement of steel? So the majority. So I would assume, and based upon talks that I've had, and everybody knows what happens when you assume, so I'm going to actually make myself probably look like an ass up here, but typically what happens is the erection community or the contractors that are involved in this use surveyors for a number of reasons. Number one, they want to release the liability issue. They always want a surveyor to come out and actually do it because I don't want the liability of checking it. Well, the reality is you take more control over your process and you minimize that liability by using your own people and using your own process to understand what's being done, because a lot of times surveyors aren't contractors. They don't analyze the result, they just simply report it. Your field people have the ability to analyze it, understand it, and create a strategy to move forward at a much faster rate. I think the other thing is that the technologies tend to be intimidating. Most companies look at this and understand, well, surveyors use it, it's always been difficult, we might have tried it in the past, or we've seen other people use it. It was intimidating. We've really simplified the process a lot. We recognize that contractors don't live in the same world as a surveyor does. Oftentimes they're not trained in civil engineering or surveying, so we've tried to simplify that, and I think you'll see in the demonstration today we've done a pretty good job of that. So for most situations, you're going to get enough of the structure up to actually support when you're placing objects, whether they be trusses or columns and that sort of thing. In many cases, some of those structures are unsupported or just partially supported, and you're going to have to make sure that they're in the right position when you make the connections. That's awfully difficult. Sometimes you put things together until they're quote-unquote finger tight, then you do your plumb checks, understand the positioning, make sure it's right, and then lock it down. That's often done with tape measures, levels, theodolites, digital theodolites, things like that. They're often difficult, and in many cases you have to put people up on top of components or up on structures that might be unsafe. We've got some techniques that allow you to minimize that and eliminate those safety risks, and I'll show you some of that as we go forward. So I want to show you a case study. If any of you are in the room, you might recognize this if you were a part of it. I'm not sure who's here. But this is relative to the Denver Art Museum. Is anybody familiar with that project? Okay, so this was a pretty sophisticated project. It was a renovation of an existing facility. As you can see, there's an awful lot of steel construction that went on in this project. Quite sophisticated, lots of components. Here's some of the contractors of record on this project. I think you'll notice that Tekla is very well represented here and for a very specific reason. So here's a picture of it. So this is the finished product. Obviously something that's not the simplest project in the world to create, whether you're designing it, detailing it, or in this case involved in the erection end of it. Here's another view of it. Big cantilever design. I'm frankly still amazed that this can even stand up looking at the way it is. Here's an example of one of the connection points. Needless to say, you've got tons of connections in all different planes. I don't know that there was any perpendicular connection in this entire facility. Some of the challenges in the process. So certainly due to that complexity, the entire design team had to produce 3D models. If you weren't involved in the 3D model process, don't bother being a part of this project. The contractor is required to produce complete and exact 3D detail models. So it went from design to a truly very detailed detail aspect of the modeling. The 3D model was created, maintained by the architect in Form Z software. The 3D coordination was so important here in one respect because of the MEP design. You can see how difficult that design was. It was very difficult and very sophisticated running MEP systems through that building. And the ability to maintain that steel structure in the proper position allowed for these MEP designs to be actually implemented in the building. The connection detail proved particularly difficult. With some of these connections had 10 structural members coming in at 3 different planes. Really, really difficult, like the example you saw previously. There was no typical detail. Virtually every connection was different and every connection was unique. And then finally, what I think is most critical here is that in spite of all of that, the steel construction aspect of this was completed 3 months ahead of schedule in spite of a slow start. And it's because of the techniques and the workflow issues that they implemented at the very beginning in pre-construction. And I'll talk a little bit about that as we go forward here. Relative to the field aspect, the proper positioning of the shores was critical. Obviously, you saw this was a cantilever design. Making sure that it was shored properly to make connections was really critical, so that you wouldn't have overstressed conditions. The complex geometry meant that conventional alignment techniques wouldn't work. You couldn't simply hang a plumb bob with something and believe it's in the right position. You couldn't use a digital theodolite and sight to a position on a structure and say, oh, that's good. You couldn't pull a tape measure and measure this way and square it and say it looks good. Those things didn't work. You had to use very advanced techniques. So what was done here was a structural steel alignment plan was developed by the pre-construction team. In this case, the XYZ coordinates of the 3D model, of the detail model, were all pulled out. All the primary columns were detailed and fabricated with drilled alignment holes. So the fabricator actually produced the steel structure with drilled alignment holes, which can hold a prism like that allowed the steel erection company, when they were placing the steel components, to mount a prism that could be tracked by this device so that they could monitor the placement of those components to make sure they were precisely placed and know what the movement and deflection was as they were being placed. This was a really unique application and one that I think is going to go forward here. Now, obviously, this is a really sophisticated structure, complex as well, but these techniques don't have to be used primarily for sophisticated structures. Picking up, I was noticing the logo here on the Steel Erectors Association. You know, picking up a piece of steel and placing it in midair somewhere is difficult. You know, knowing where it is, knowing where it's supposed to be, and making the comparison between the two is critical to success and accurate success. So some of the takeaways from this: it was a highly complex design. The planning was done in pre-construction. That's critical. Tekla was used primarily and consistently throughout the project, and that's because of the level of detail, the fabrication capabilities out of Tekla, and the ability to actually export data to these devices. Like we're doing here, yeah, so in this case you can go 150 meters. Now keep in mind that the red dot is limited outside because of the brightness of the sun and stuff. However, you can still use the crosshairs in the scope, and I can look out 400 or 500 feet with the crosshair and understand what I'm seeing because it's got a really high magnification. Okay. So typically what we do is we go through about a half-a-day process of how do we get data out of the model, you know, creating the data out of the Tekla model. How does it go in here? How do you manipulate things in here by adjusting points, you know, deleting points, manipulating data? Then the rest of it is you go out in the field and you use it. We go along with you. We teach the person how to set it up, what the best practices are for setting the instrument up, how to measure properly to make sure you eliminate the error potential from plumb error and things like that. And then we simply walk through the process on an active job site. It's not where we take people out of the field for 2 or 3 days at a time. We want to do it on site, working on a project. And usually the most difficult thing is to focus on the most productive and the most useful techniques that you need at that immediate time. If it's laying out anchor bolts, or if it's measuring existing site conditions, or it's placement of steel, we focus primarily on that and let the person get used to that and understand it, and then come back in a week or two and kind of work through some of the issues that develop. Typically between 1 and 2 weeks, somebody's working about at their max productivity level with it. Yeah. So it's a very simple system to use, very easy to use. It's a one-person tool, and I think it helps to really streamline the workflow dramatically. Okay. Yes, sir. Mm-hmm. Mm-hmm. Mm-hmm.
Back-end model, make fieldwork drawings for base plates, fix the base plates where they land.
Yeah, so what we see a lot is people that We've got, and actually what we're trying to do is we're actually trying to modify the software to even enhance that further. What we'd like to be able to do is to be able to measure anchor bolts, for example, and understand the orientation of the bolt. You know, we can measure the top center of the bolt, but that doesn't do any good because the top doesn't always line up with the bottom. We need to know what it's doing this way. So what we're trying to do right now is to figure out some accessory components that we can use to understand that orientation of the bolt so that it can be brought back in to say that bolt starts here at the base plate and it does this. So from a fabrication standpoint, you would know whether you had the ability to widen the hole on the plate on the column to move over it, or if you had to simply go back in and replace the bolt positions so that you were more plumb. So we're trying to advance that and really get very specific about how to do that. So we would absolutely welcome ideas anybody has in here on either applications or techniques that would help you guys. So if you have them or you have thoughts on what we could do to make this software function for the steel industry, please let me know. I'll give out business cards to everybody. Call me, email me, let me know what would work for you.
I've actually got just one continuation just on that previous question about importing. This is a file that Jim and I had made earlier, and I've gone into the import section of the Layout Manager, and I'll just open that file and import those guys in there. And another thing that you can actually do is you can change the style of, we're showing them here as spheres, but the ones that you import, you can adapt them to report different features or different parameters. For example, if I go ahead and click on it, give it to me, you can see there that we've got various different shapes, so that even looking on a grand scale view, you can spot differences between perhaps something that's for an anchor rod and something that's for like a face of a concrete wall or something like that as well. And you can also give it names and identifiers as well, so it's easy to when you bring that stuff back in from the field and bring it into the model, you can easily identify it in the model and correlate it with what should be there.
Do we have some? Yeah. Good question. So this instrument's accurate to a 64th of an inch over its entire range, which is 800 meters. So it's way more accurate than we'll ever need to get. So I think the best way to put it, what we typically say is using best practices, you can be assured that you can get within 1/4 of an inch on everything you do. If you want to get better than that, it just takes a little bit more time to actually get to the 1/8 of an inch tolerance if that's what you're looking for. But you can always be assured that you can get to 1/4 inch. Yes? Uh-huh. Sure. So if you're in that situation, there's ways that you can do that. We have a direct integration with Tekla. We have indirect integrations with other packages. We're in the process of doing one with Vico. If you work in a CAD environment, as long as you have a DWG or a DXF, you can run it through CAD and bring the points in that way or send the points out that way as well. If we don't have the direct integration, for example, with Revit Structures or Bentley or something like that, just export a DWG. You can create the data there, move it out to the field and back again that way. It's less capable of comparing within the model itself, however, than it is in the Tekla integration. And that's because they've implemented some direct SDK implementation into their software that ties directly to our device.
There's also a good chance as well that any kind of file that you can get, a DWG, a Revit file, for example, anything like that can be brought into Tekla at some stage as well. So maybe your best bet might be just convincing the guy to give you something that you can put into Tekla, or setting Don Grigg loose on him and making him buy Tekla.
Yes.
Is the distance measuring by infrared or GPS?
Yeah, good question. So this is not GPS. It is infrared laser. So this device is sending out an infrared pulse that either reflects off of the surface or it reflects off of the prism, and it's essentially how fast it goes out and comes back, and by the physics of light it knows what the distance is, and it also tracks angle as it moves. Yeah. So the whole kit runs about $40,000, depending on how it's configured. It's between $35,000 and $40,000. Yes, sir.
Yeah, I was thinking about the anchor bolt. Most of the time you just get the cross bars, then you can feel there's for that. But like you get anchor bolts that are 3 foot in the ground,
Yep.
you'll be able to read it.
Well, obviously you have to have line of sight, so you have to be able to see it. So the pole obviously can be moved up and down. If it's down in a hole, you might have to position the instrument several times to be able to see different footings that are down below where the anchor bolts are located. So it's typically, there's a process you go through to position the instrument to get the best view of the most measurement positions you want. If they are deep, then you would typically use the pole and use it, so the pole is longer. And then we've got some stabilizers that allow you to actually run the pole up and stabilize it and make sure it's plumb. So what you're measuring down here is the same as what you're measuring up here on the prism itself. Does that answer your question? Okay. We've actually seen it used also where people are going out and taking some measurements of rebar and things like that to understand if there's going to be any conflicts between base plates and rebar placement. You can go out and check placement of rebar pretty quickly and compare it with the design model for your base plates to understand if you've got any rod positions underneath the plate that are going to be confused or conflicted with the rebar itself. So I think there's a lot of different uses for it. I don't even know if I know what they all are. I'm a fairly new steel industry person relative to the techniques. And as I said, I'd certainly love to and welcome any suggestions you might have or invitations to come out and kind of show you what it does and learn a little bit from you as well.
I would offer up that you should create an application to make the damn concrete do what it's
So that is our goal. That's why we sell this. But I will say that has been one of the slowest industries for us to take up this particular technology, with the exception of, oddly enough, residential poured wall foundation contractors. They were the first industry for us that really picked this up and ran with it. And that was about 6 years ago. And then the housing industry went like that, and we had no more business there. But you're absolutely right. When we've talked to steel companies, that's the first thing they say, is get the concrete guys to get the right equipment to do it right the first time. But I also see that there's applications outside of just the anchor bolt placement. I think obviously placement of steel and existing site, because there's so much renovation and rework going on right now. The ability to know what you have to work with in order to do your model and design and detail is really critical. Yes?
I have one question about the demo project you're talking about.
Yeah.
We have those elevations of the track locations. If for some reason it moved overnight, would it change the next morning?
Only if you shoot to it and measure it. It's not a consistent measurement unless you had the instrument sitting there all night and you came back and looked at it the next morning. But it's very simple to set the instrument up, go out and shoot your resection to position it on site, and then just sight to the places you left off with yesterday, take a quick measurement, and you'll be able to see immediately whether it's moved overnight or if it's been bumped or settled or there was overstress. Yeah, absolutely. So you can go through and you can consistently check these positions over time, because obviously there's shrink and swell in the materials as you go through the seasons and things like that, or even through the course of a day. So yeah, it's quick to set it up and take the measurements. Okay? Thank you, guys. If anybody has questions afterwards, feel free to let me know.
Thank you, Jim.
You're welcome.
Hello. All right, you got me up, partner? That's very good and very exciting, and thanks for the questions, because we like for it to be interactive by all means. And the cost is what it is. It's like Tekla's price is what it is, but it doesn't matter what it costs unless it's something that can help you and help advance your business in the right way. Speaking of cost, I got something good to show you. That's something that Tekla introduced a few years ago, and actually, to tell you how bad of a salesman I am, I'm not even here to sell it to you. I'm here to give it to you. So I've got a free product that you can download off our website, and we call it Tekla BIM Site. Has anybody heard of Tekla BIM Site before? With a raise of hands. All right, me and Eddie. Okay, and then one in the back. We're good then. That's right. Oh, and for the record, with one more presentation, Ian's going to earn his blue jacket. So let's all give him applause. With cool buttons. All right, so what we decided to do and what was happening is we had general contractors, engineering firms, and they were demanding to our steel fabricators to use and have different types of models, like a Revit model, or even a Navisworks type model to be Navisworks compatible, and I'm sure you guys have heard of those two products. And what was happening is, and what is happening is our fabricators who have Tekla, they realize, as we realize, that Tekla has a far superior 3D modeling system for construction. Well, what does that mean? What we mean by that is with Tekla's 3D model, you've got real steel, you've got real washers, you've got real welds, you've got real material. It's a real model, and if you guys who have Tekla here, you can attest to that. Tekla knows how much it weighs, where it's at in the XYZ world. It knows all the pertinent information it needs to know to help the steel fabrication process. So what we decided to do, instead of charging $10,000 to $12,000 for a general contractor to have a product that can be compatible with Tekla, we decided to give it to them. But in the meantime, as we're giving it to them, we're also giving it to everyone else. So again, it's a free download. Bruce, you got me? It's a free download, which makes it even more valuable. So with all that being said, it's something you can grab. It is a tool, as we mentioned, just like Tekla Structures, but it is not Tekla Structures. It's called Tekla BIM Site. And it's designed to help you do construction management. It also helps you do some internal management. Also can help you communicate with other facets of the industry. So I'm going to attempt to give a quick demonstration of what Tekla BIM Site can do, if you will. Now, right now, I'm sorry. Even so easy, a golf pro can do it, a former golf pro. Right now I miss Dave Schultz because I know he'd be raising Cain at me right now. Because what you can see here with Tekla BIM Site is you see a model, and you see it's up, but it also has the architectural as well as the interior of the building. It doesn't have the chairs and the toilets and all the other fun stuff, but it does have the construction part of the Tekla. Well, as some of you guys will say, well, hey, we don't do that. What we do is we do steel, and that is what we do. So once you open a model, now we'll back this up even further. I'll add a file. The first question you might have is what kind of files can this program import or open up? And then you see on the bottom right there, hopefully you see that. Yeah, it's hard to read. IFC. And IFC is the Industry Foundation class, and it's becoming a very primary file, a common file for the construction industry. IFC stands for Industry Foundation Class. In the middle 1990s, the IAI, the International Alliance of Interoperability, they got together and created the IFC, which is Industry Foundation Class, and it gave each different discipline a different class, a different number. Like concrete had one, rebar had one, HVAC had one, steel had one. So each one had their different number. So what has happened here, oh, very good. Very good. Oh, yeah, that's very good. So with all that being said, what you can do is import all the different disciplines that will provide you with an IFC model, a DWG model, a DGN model, okay? Now, this is the first run, and I don't know if we can call it version 1 or not, but with this version of Tekla BIM Site, it's new. So as you guys have seen in the past with new software, it tends to grow, it tends to add more functionality, and also tends to add more features. So if you notice, once I have the models open, and again, there's 9 models open right now inside this model. As I open it up, you can see on the left you've got the different models that are involved, and as I click the I, you can see some of the models start to disappear. Let's bring the crane back. The crane's kind of cool. So you see now we're at more of a structural model with the platform with the concrete there as well. Okay, and on the right side, because my resolution isn't where I need it, can't even see that. Let's see if I can get that over just a little bit. Objects. On the right side, I can actually take it to a further level, and I can start, there we go, I can start getting rid of slabs and start making it look like something you're a little more used to, more of a structural model. Also inside the model, I can clip planes. I can, if I want to take a closer look with Tekla, oh boy, I'm thirsty. I can add a clipping plane, and if you have Tekla, you understand that with these little, what we call clipping planes with the scissors, you can zoom in or out, and you can see where something's classing or not. And then once you get to that point, wherever you hold the mouse and wherever you zoom in, as you scroll your mouse in is where you're going to go. Okay. And you can do that from the top or from the bottom as well. So in the disciplines we got in here, we've got MEP, we've got rebar, we've got some footings in here, we've got the architectural model, and of course we have the steel model as well. Let me back up here a little bit. Okay, also, this is really cool. Once you get a little deeper into the model, if you got a question about what something is, and you can see with this model as well, you can see bolts, you can see connections. You know, it's a pretty detailed model, and it's very easy to navigate, and it's very easy to learn as well. But once you come in, you can take a member, right-click, and it'll bring up the properties. And if you notice, I click on the properties, the right side will show a ton of properties of what consists of that beam, including the piece mark, including the size. Now, since we're giving the software away for free, we're not really offering any training. Okay, why wouldn't we offer training? Well, Tekla's BIM site is easy enough to use that we have online training where once you have the software, and once you download it, and again, you download it at www.teklabimsite.com, then we have some learning videos, and they're really, really nice. There's over a dozen videos that you can go in. They're all about a minute long, maybe a little longer, and you can honestly learn how to use Tekla BIM site. So if you got your weekend off, or if you're in your office and you're twiddling your thumbs or whatever, and now's a good time to implement something new like this, since some of you guys are slow. It's also a good time to implement something like Trimble. It's also good to implement something like Tekla Structures. When you're slow and you got some downtime, it's a good time to learn something new. And with Tekla BIM site, and because we don't offer training, you can come in here and hit a video and learn basically the function you want to do. Very, very nice. Also in Tekla BIM site, you can measure. I'm going to back this up a little bit. You can pull dimensions. Over here. So if I wanted to see the distance between, now this is going to be fun. Between here, don't laugh, and there, I can just pull the dimensions. So you can see from bolt to bolt, from end to end, from base plate to base plate, whatever you want to do, you can pull a dimension on all day. Also, you can add notes. And this is where the communication comes in. If you have a problem, or you have a question, if you don't know the type of steel or whatever it is, or you guys are a little bit different, or if you want to go back to your guy and say, hey, I need to know how you want me to erect this, you can zoom into an area, beautiful here, take a snapshot of it, it comes up here, give it a name, and you can say WTF, and that stands for Welcome to Florida. Did nobody get that? Okay. It just wasn't that funny, I guess. Welcome to Florida, and then there it is. Type A. There we go. Then just save it, and then reuse it. And then from there, as you save these files back and forth, what you'll do is you'll create what we call a TBP file. And this TBP file you can send to anyone else who has Tekla BIM site. Well, if Tekla BIM site's free, why would they not have it? So you do say, here, check out this file. I've got a question for you. Go download this for free and take a look at what we got. And actually, you can send many notes, and all the notes will come with Tekla BIM site as you create a project with it. So if I have one earlier, I can just click. You see it goes right to it in the model, and I'm going, what the heck is that? Welcome to Florida again. I'm going to go over here and say, all right, I got a clearance problem. This is not going to fly. There's something hanging out. Okay, then also, as you're doing the model, you can always go back and go to any view you want to, because in the bottom you have something called Save Views, and this is in the videos. So you say, well, I'm getting a little confused here. I got too much on my plate. What's going on here? You can go back to the start of the screen. You can go back anywhere you want, and at any time, you can turn on and you can turn off views at any time. A lot like Tekla, but again, this is definitely not Tekla. Okay, also with this, you can check for clashes, or conflicts is what we call them, conflict detection. And basically, I asked a steel erector earlier, I said, is this really going to benefit you guys a whole lot? And, it's kind of iffy. However, if you're looking to say, all right, in this situation, in this complex erection sequences, are we going to need to use a spud wrench, or how are we going to get this thing in there? So if you use the clash detector, if you will, conflict detector, pardon me, it actually will let you come in there, give it a tolerance, and say, all right, anything within 3 inches of this area, I want to do a check and see if it clashes. So you can do a lot of checking yourself. Okay? Any questions so far? That's pretty easy. Okay. Well, very good. But the key is with this product, again, being free, anybody can download it. You can share information. How much is it? Duff asked. Altogether, Duff, it's free. There you go. But the key is you're going to be able to communicate with different facets of your industry, and also it's designed to help our users, the Tekla users, become a little more friendly in that environment. Because again, they're getting hammered with these questions all the time. Well, I need to be BIM compliant. Okay, well, Tekla's BIM compliant. Where's Tekla at here, partner? That's no big deal. I want to be IFC compliant. Well, Tekla's IFC compliant. Well, what we're hoping is going to happen is they're going to come say, I want you to be Tekla BIM site compliant. And inside of Tekla structures, instead of you worry about creating a file and getting crazy with this, and you're going to like this, Richard, there's a Tekla BIM site publish button that you hit, and it takes it to it. Very, very nice. So again, it gives our guys a leg up and gives them another advantage in the industry. So not only do they have a more detailed model, although we know we have a better platform for BIM, we're giving a product for the general contractors to learn more about Tekla, where they can come download it for free and check out the different disciplines in their business. And they also can manage the business and the project with Tekla structures. Okay, so combine and review. As you can see, we can identify conflicts, advantages and disadvantages to that. The one thing you guys learned about Tekla, and the guys who have Tekla, if it's modeled correctly, it's going to fit in the field most of the time, and I agree with Bruce on that. It's the concrete guy's fault, and I don't mind saying that. Most of the time, I will say. So if you're communicating back and forth with your general contractor, now he can communicate back with you at no cost. He can send it back to the erector and say, okay, here's what's going on. If he has Tekla BIM site, this footing is off a foot, whatever it is. We're going to get it corrected, or we went to the fabricator, we need to make changes, or we need to revise, go back to an engineer, or however this is going to play out. So again, at the bottom you'll see there, it's www.teklabimsite.com. Quick review. You've seen, hopefully today, you've seen and you remembered, I'm sure you remembered, you used the model for planning, sequencing, and layout with Tekla structures, especially for the erector. The use of Trimble integration for verification and alignment, amazing tool, as is Tekla structures. And the Tekla BIM site can help you report conflicts and, of course, share data. And the key is this whole thing, and that's, you know, my father was in the construction industry all my life. And it still blows my mind back in the day where I would go out to his job site and he had drawings from the concrete guys. He had drawings from the steel guys. He had drawings from the HVAC guys. And his job was pretty much to put all this together and make it fit and make it work. And that didn't always happen, and it's still not always going to happen. But in the year of 2011, you know, you have technology that can get you there much quicker, much faster. And what we're hoping is the Tekla players, the people who own Tekla, or they've already got a leg up on the industry, we feel, we're going to help them have a even larger input in the industry. And when they're doing their marketing, when they're doing their research, when they're doing their investigation into new projects, they're able to take this model forward and be very, very BIM compliant using Tekla. Any questions or anything? Boy, that's pretty good. That's not too bad. Okay, does anybody remember the website? I got $100, but I don't have it with me. Okay, very good. All right, well, we would like to thank Duff, and we'd like to thank the SEAA for letting us have this opportunity to speak. And as always, if you have any questions, Mark's going to sneak out back. Don't hesitate to talk to Mark about pricing of Tekla. The Tekla project for erectors actually starts at $1,000. The Tekla BIM site is free, and Mark did tell you how much the Trimble is as a package. So thanks again for coming, and we hope to see you soon. Thanks again.